I want to go over why it matters in the weight loss journey and in health in general. So, a coding gene determines things that we cannot change, right? It's coded for that specific thing, such as your eye color, your skin color, your hair color. These pretty much, to these types of genes, you can't really change. And believe it or not, this is the least amount of genes in our body. The bulk of our genes are actually the non coding genes. They make up over 90% of the genes in our body. And a long time ago, when we were first discovering genes, these were thought to be useless because we're like, they don't code anything. They don't code your eye color. They don't code your skin color. They don't code your biological sex. So, what are the importance of these genes? Well, they ended up finding out later that these are considered the cause of many regulatory functions, and we'll get into that. So, these genes are actually very important in our health and weight loss. So, these are the genes that are predominantly that play a role in our health, and these are the ones that in this program I will be going over with you. It's the non-coding genes. So essentially, they have the ability to activate on and off these non-coding genes, and that changes the way these proteins are expressed. So essentially, this has the non-coding genes are the ones that are responsible for medical problems. So they're responsible for diabetes, switch turn on or off. They're responsible for how our hormones respond. They are responsible for how we respond in times of stress, on or off, good or bad. You know what I'm saying? So these are the non coding genes, right? They have switches on them essentially. They have now, these genes have what we call epigenetics, and they have the ability to activate a gene or repress a gene expression, this is the genes that are predominant play a role in our weight loss journey. So I just kind of wanted to break that down. Most people don't have a coding gene to be overweight. These are non-coding genes that have the ability to activate that gene, and then it becomes coded, right? Then that it becomes expressed, or repress that gene and it does not become active, so it's not expressed.